So as everyone's getting their seats, this next group of projects is very interesting because every year at ACAW, we keep it a mystery as to what all the teams are doing from each other. And part of that is obviously that they all want to compete with each other anyway, so you don't want to have them doing that during this process, as is we all are nice people and we all want to get along. But something always emerges, and this is like what's in the air, almost a gestalt that's in the air. Like one year it was sunlight, and the sun was the focus, whether it was harvesting energy or whether it was about reflection. Another year was all about plants, biophilia, and a variety of ways in which, and it wasn't, obviously they didn't know what each other were doing, and it was just a concern and an interest that was in the air. This year, especially, we sort of seeing a confluence around water. And this was not just also experienced with you'll see these projects, but also some of the work the academic teams are also investigating. So I think it's always a very interesting thing that sort of emerges out of that. So with that, let me introduce Behnisch Architects, who will get us started in the second half.
I'm so impressed that you can pronounce the name of our firm correctly. You're like the only person ever introduction. There we go. I'll start. I don't want to take up valuable time. My name is Michelle Lee. I'm here from Behnisch Architekten. Thrilled to be here. I'm joined by our amazing team members, Knippers Helbig, who not only did facade engineering, but were really integral to the design process. We're actually all trained architects, so we designed it together. Transsolar climate engineering. If you don't know them, they're climate engineers. So there's a huge focus in our project around climate and doing very scientific, methodical studies of the performance of our facade. And then finally, we have TriPyramid, Molly Wagner over there. She's our amazing metal fabricator. And just like, how did we get together? We've been working together for years. I've known Pamela and Shamil for a long time, and Molly. These are some of the projects that we've worked on in real life. And I've been wanting to do ACAW ever since I saw Stan, Sue, and Corey Brugger present their work at Morphosis. I've been dreaming about doing ACAW. So we finally got our act together and applied. And we're thrilled to be here and meet all of you guys. And I'm going to try to do this thing where I bring as many of the other presentations in our presentation, because just to keep you guys all awake. So this is a reference to Gustav's keynote with the Olympics. He had this Olympic-themed presentation that I thought was timely. But these are some of the projects that we've worked together with Molly's team, Pamela and Shamil. And we thought Terra would be a great kind of completion of this kind of constellation of work. So with this amazing opportunity, it's kind of like, it's such a privilege, and what do we do with this? So we thought, like, in the absence of clients and all these constraints, what's like the biggest problem that we can tackle right now? And for us, it's climate change, and in particular, the urban heat island effect. We all come from urban cities, Berlin, Lima, New York, Boston. So it's kind of a global issue, right? And when you think about facades, Mick Patterson has this facade tectonics slogan that's better building through better skins. And I think we can expand that and say better urban spaces through better facade skins, because we know the cumulative effect of all this building material is not just about the people paying for the building and the clients, but it's about the people who are occupying these urban spaces. So just like everybody knows this, but the trend is going in our favor. People know that the glass is a problem. We're already seeing this being, mandated in many progressive building codes. The United States is probably not the most progressive. In Germany, we have lots of competitions where we have to actually design green facades or green roofs, right? And this is really important for us. Our office is actually located right to the east of this gate. This is Chinatown in Boston, and it's really one of the most incredible communities in Boston. I'm a little biased because I'm from this area where these immigrants are from, Canton. And it's really one of the only urban spaces where people aren't looking at their cell phones. People are hanging out. Their grandparents are, babysitting their grandkids. It's a really important part of the community. Play. I don't know what's going on. Ryan made this. Oops. Sorry. The videos are always.
There you go.
Oh, I just click on it.
Yeah.
Sorry. Okay, I got to do the two-handed thing. So Ryan Mariyama from our office made this kind of scrolling tapestry that kind of shows, what this community means to us. And our office is right up here on the second floor. So we just kind of put this together because they're kind of our clients, right? Since we don't have to design for a client, we want to address this issue. And then also thinking about the technique, right? What's existing? A lot of people have talked about that. Arab, you had those beautiful photographs of the buildings in England. But for us in New England, it's the Cape Cod, it's the shingle. It's easy to build. It's a very robust way to shield yourself from the notorious New England winters, the marine climate. Also, we have a huge body of terracotta work, obviously, that has been around for hundreds of years. This is one of my favorite buildings that's now a Starbucks. But okay, so early on, we did all these like crazy studies. We were so excited. And we did these I think before we talked to Andy and Andrew, and after we showed him, most of these were not even, they would be very tactful and say, okay, well, is it important that this goes to market? Would you actually, want this to be affordable and mass produced? And we're like, yes. So he's like, okay, don't do most of these. So one of the presentations yesterday, I think, University of Michigan, they told the students to work with the rainscreen, to start with that and then start building off of that. So we're kind of doing a hybrid between two typologies that we know work, that have been around for centuries, and we're just trying to operate, take 2 inches and see what more performance can we get out of that, right? So instead of just reflecting the water, we saw the same slide, right? It's the zeitgeist. We're trying to spread water over the surface like a shingle, but instead of running straight down, we're trying to make it run diagonally and slow it down as it runs through the building. Does that make sense? So why does the module look like this? Well, first of all, the shingle, the brick, it's an ingenious way to make something modular so that people can actually install it with ease. One person actually, when Eric is the only one who can kind of just carry it himself. And this is the perspective from a raindrop, right? So if you're a raindrop, you're going to be traveling down this ridge, and then you're going to go to the sides where we kind of turned up the lip of the shingle, and then you're going to travel through these miniature canals that are these grooves and into the weep holes. So it's just about slowing the journey down. If that makes sense, you can take a look. Just playing with gravity, movement of water. So the second module, that was the first module. The second module is a little bit different. If you look up close, they're actually not the same. It's kind of inverted, and it has these little textures that are made to absorb more water. And these are allocated at the lower part of the building where people are hanging out, because we don't need evaporative cooling where there are no people. We were also looking at these amazing, bizarre, rusticated podiums that you see in Renaissance architecture and neoclassical architecture, where it looks like these weird grotto patterns. And they're always at the base of the building because they're referencing, the earth. At the top here, you can see a little more detail. This is one of them when we're installing it in the shingle method. And then the third module, which is at the top. Wait, I don't think this works when you point laser at the model. The top one is the screen module. And it's a way for us to integrate, apertures and think about sun shading, but then working it with this opaque surface that we have. And then we decided to incorporate these trellises to continue the green planting theme from last year, but maybe not make it like an actual planter, because in New England, that just wouldn't work, right? Freeze thaw issues. So these easy Ivy League type light trellis. And then the picture on the right, I took at the Martin House during our lovely evening, and they have the same system that we have. I'm pretty sure we came up with it first. So the evaporative cooling tiles, Ryan Mariama from our office spent a lot of time developing this tile because this is the most important one to radiate the cool moisture at the human level. And he did a bunch of these studies, and those were the bounty tests, to test how much water, how long it takes. So that drove our design, along with the kind of drill bit. What's the resolution that we can get? Obviously, we want really tiny pores. We saw that with a professor from the University of Michigan's presentation, Professor Ng. These beautiful woven things. We tried to do it, but like in the texture of the surface, so it can function as a rain screen. And then also mold release. So toolpath, mold release, and then water was what drove the design. A little bit about working with Andy Brayman. Hi, Andy. So these were all the glazes that we were looking at. And we actually wanted to do some amazing color. I love Celadon, cobalt. We realized that it was like toxic and terrible. It's like you want to do some amazing texture, but unfortunately science told us that the lighter the color, the more reflective, as the UN Studio people presented really well, that was what we wanted for the step form. So we actually only glazed the top, like the eyebrow, right? Because that's where the sun hits, and you want the sun to bounce off of your eyebrow. And then in this part, you want the water to stay there. So that was the concept. And I love this construction document that we sent to Boston Valley at the conclusion, where it's like, spray the tile from here, try to hit it. And Matt from Boston Valley when we saw them on Monday, we were blown away. They came out so much better than I thought they would, especially with this kind of like direction, right? So the idea is to glaze the top like a glazed donut, get the sun to bounce off, use the clay body to absorb as much water as possible. That was the concept. Shamil.
Yes. Luckily, I'm not wearing the same shirt in this picture, but there might be other ones where I am. I guess everybody's in that boat at this point this week, but yeah, so the support systems, this is just us assembling, but looking at a typical kind of wall section, we really wanted to develop a system that we could put on a building and adapt to all the different wall types we would have. So the main opaque parts of the building have a shingle tile that's just face nailed, similar to clay roof tiles. And then the other part is a lightweight cable wall with a tile screen that can provide shading over the glazed areas and also for roofways. And otherwise, it's the tile system is a typical kind of rain screen system. So it's current technology, but bringing all of the parameters that Michelle talked about into this kind of idea that can just be applied to a project. So these are some really awesome fabrication drawings from TriPyramid. Thank you, Molly. And We wanted to incorporate both of those support systems into the prototype. Zooming in on the hardware system, our goal was to kind of minimize it as much as possible and foreground and highlight the terracotta. So I think we were successful in that. I think TriPyramid, obviously, we're working with the best in the game, so that was never in question. This little detail right here is the stainless steel outrigger. It looks like a continuous cable from top to bottom, but there's actually two cables with a special coupling. The upper cable, which is load bearing, is pre-stressed, whereas the lower cable, which is not load bearing, we can install it without any pre-stress. And the cable clamps, another little beautiful detail from TriPyramid that we worked with TriPyramid on. We're really OCD about this detail. And Molly was very patient with us as we kept asking for the screws to be, she was like, how, you want those screws even smaller? And we were like, kept had a little back and forth, but yeah, so we wanted to keep the height of that spreader arm to be in line with the depth of the tile, so it kind of just disappeared as much as possible. And we did a bit of engineering at Knippers Helbig. TriPyramid did some of the hardware, FEM. We did the cable wall analysis, and one of the things we tried to do also is just in general, considering the responsible window to wall ratios, we wanted to keep our glazed openings to about 6 feet max, which also helped keep the tension forces in the cable wall down. And the cable wall is a really lightweight system. We'll look at the embodied carbon of it in a minute, but we didn't want to introduce really high tension forces, which would kind of counteract the efficiency of the cable wall by requiring us to have a really beefed up backup structure. Do you know?
Yeah, thanks. I'm just going to talk a bit about the circularity and embedded carbon emissions of our design. So first we have the baseline option, which is what you see actually we started with doing it from aluminum substructure. Normally the amount of recyclable content in aluminum is 55% in North America, as you see in below. And so we ended up 230 kilograms CO2 equivalent per square meter, but then we upgraded with the aluminum with having 80% recycled aluminum content. So you can see we ended up with 150, and then if we add more 20% to the recycled content, we're going to have 101. But if we go for the timber substructure, we can end up with 79 kilogram CO2 equivalent per square meter. Well, of course, you have to check if it's allowed according to the codes in North America. And then you can see on the right that the stainless steel tension cables, they can even reduce half of the carbon footprint of the module. And for circularity, so the basic rule is we want to integrate as much as possible virgin materials, reduce the virgin materials as much as possible and increase the recyclable content during the production. And this would also, we have to think about increasing the recycling potential of material at the end of life process. So at the beginning, we had 58% of circularity, where the terracotta tiles were downcycled as crushed aggregates because we had the glazed terracotta. When we reduce the terracotta glazing less than 1.5 millimeter, we end up having 100% recyclable terracotta. And if we add also 45% recycled content for the aluminum, we end up rising our circularity for 81%.
Hi, everyone. My name is Pamela. I'm from Transsolar, and I'm going to go back to one of the topics that is the main topic really driving our design that Michelle introduced at the beginning, which is the thermal performance of the facade. This is a picture from yesterday. We were testing it at the last minute and seeing how the mock-up performed as well. And just going back to basics, and I know this is probably familiar to most of you, what is comfort is first understanding how are we going to impact outdoor comfort in our cities. And like most of you know, it's not only about air temperature, but all these different factors that impact the heat loss and heat gain to our bodies. So it's air temperature, humidity, but also the surface temperatures of space of walls around us and surfaces that define the mean radiant temperature, air velocity, and other things like clothing value and activity. And there's different metrics, but right now for a study, we're using SET, which is the standard temperature and cooling temperature. And it basically defines the perceived comfort temperature of a space so that you don't rely only on air temperature, but on what it actually feels like. So in a simple example, we can compare how the same space with a higher air temperature going from 78 to 83 degrees Fahrenheit feels the same if the surface temperatures around you are decreased by 4 degrees Fahrenheit. So at the beginning of our studies, we did many tests, and these were done with the samples that we received from Boston Valley to Cotta, and we analyzed how cool the surface temperature can get. And this is a sample because there were many of them and also related to the glazes and the bodies, etc. But what's interesting is that we were able to actually reach the wet bulb temperature of the conditions of the experiment and reach temperatures that could show a delta of 18 degrees Fahrenheit to ambient temperature, to basically air temperature. What was interesting in the mock-up testing on the bottom, we also saw this same similar reductions of surface temperature from air temperature. Here you see the starting condition at the beginning. The wall was the same temperature as the wall behind it with a similar color. And after 10 minutes to then an hour, you'll see more about this. It was reduced by 18 degrees. And we wanted to simulate this in an outdoor condition. So that's Behnisch office right here. This is the Chinatown neighborhood that Michelle was talking about earlier. And I wanted to just take as a first step, and there's many more studies that should continue after this canyon condition of a lot of buildings that have brick facades, where we can evaluate in an effective way the outdoor comfort and the SET of different several points across the sidewalk and the street here with different surface temperatures. Based on the experiments that we saw and how cold we can get the facade of terracotta in comparison to the wet bulb. So I'm going to go a little bit fast due to time, but here we basically analyzed how those temperatures changed throughout the day. Here we're looking at the hottest day of also the amorph weather file for the future conditions of 2080, because what we're talking about is really not historical conditions, but current conditions, and as they get worse with climate change. And you see that the SET reduces from 97 to 94 on the warmest day of the year in that future condition. It's still pretty warm, but if we see the sunniest day, which is a typical summer condition, the SET goes from feeling the temperature of 79 degrees to 76 at 4 p.m. In the same alleyway. And yesterday we did a couple more studies. So here also a little bit video of how the facade performs with the water. Because the way that we anticipate this design to perform is in a couple ways. First, to be able to prolong the cooling effect of rain events on the facade by being this rainscreen facade that has a lot of absorption and reflection from some of the glazes, but also that it could be activated on demand on hot days when you want to have outdoor comfort. And what we see here on the results is that we're comparing the back wall that you see is the same color, but it's a painted CMU, our module, and then rusted steel surface. And this is the starting condition at the same temperature of 32 or 90 degrees Fahrenheit. After just 5 minutes in, that 90 degrees Fahrenheit was reduced by 7 degrees Fahrenheit. And 1 hour after, there was a delta of 14 to 16, depending on where you were looking between the evaporative cooling tiles and the screen tiles and the shingles. We did another test also looking at this rain condition when everything was wetted. Right after the rain, the thermal mass of the wall was greater, so that still remained hot, but there was a delta T of 20 degrees Fahrenheit from the original state. And as long as we could say, after 2 hours and 40 minutes, the sign stayed cool below air temperature and a delta of 22 degrees to surrounding surfaces. Just to conclude, I think it's really interesting, and I think it's only the starting point because I think there needs to be a lot more tests based on the mockup that we have. But what's really interesting is that the shingle tile performs differently than the ECT, the evaporative cooling tile. Here you can see that this was one of the pictures after 1 hour of testing, after the rain stopped, and the evaporative cooling tile remained cooler than the shingle tiles, which I think is really interesting as we want to enhance the performance where people are staying. But this is the last slide. I was hoping we can all say thank you to Boston Valley Terracotta. This is one of the first pictures we took, and we want to celebrate everyone's designs, and it's been really inspiring to be with you all.
Okay, question time again. I will walk around. Anybody have questions for the team?
Thank you for the presentation. Super cool idea. Borrowing the name from another office here. But switching the climates scenario, if you were to do this in Boston, you know, with the snowdrift and the winter climate there, did you guys sort of thought through in terms of the snow accumulation that might happen on the shelves and stuff like that, and the melt water and stuff that could come?
I was like very stressed about that because, you know, early on we wanted to do one of these like planter 3D, like beautiful walls. But we couldn't because, you know, once you accumulate all the sand, it's going to load everything. You need more metal. It's going to break. So that's actually why we have this more shingle geometry with a slight relief. And, you know, we looked at a lot of examples like the Seaver Hall by H.H. Richardson with these crazy, you know, articulated ornamental terra. And it seems like the snow, it didn't affect it because it's still around. But I was like, all these crazy, you know, ornamental facades. I mean, if they've been standing there for hundreds of years in New England, then I think it's okay. So we try to operate within that kind of sculpted depth. But we didn't like calculate it. We were just more eyeballing. I don't know. We might want to. That's a good consideration. But that was really a driver for the geometry. Just have this slight shingle, so everything's like shedding off. But that I agree that deserves more study.
We did include snow loads in the calculation. So that the cable system with the tiles and the shingles.
Okay, Shamil did it. This is why.
I didn't do it. My colleague Karine, who's unfortunately not here, but she did that calculation, and that was basically we wanted a system, you know, that wasn't that was realistic to the loads and conditions that that it would experience in its application, so that we really wanted to develop something that we can use on a project soon, hopefully.
But I think, sorry, to add, that was a real limitation because as the climate engineer, I was trying to make more perforation and like cavities and like get water to stay inside. But talking to the team in Boston Valley Terracotta was like, first, let's try to make this inexpensive. So it needs to be like something that could be ram pressed, but also we want to avoid water actually staying on pooling, just absorbing in the actual material that has been tested for freeze-thaw.
So I'll just everything. I've always kind of thought this thing was beautiful, and I want to commend you on that. But also, your team is extremely inspiring, as all architects who've gone on to these other interdisciplinary fields. And I'd just like you to talk a little bit about the design process as a collaborative exercise. I think this is such an amazing showcase of why we should design with engineers, fabricators, climate scientists. I just am completely blown away. Good job. But yeah, talk about sort of how the first day, what was day one?
You should, because you're with a team.
I mean, first off, we just love hanging out together, like the whole friendship thing. It's totally true. When you like somebody, you're gonna do really awesome stuff, right? But also Shamil, Pamela, and Dima, we're all architects. We all love art. We love design. We love culture. So when we design the thing, we have an objective, and then we all try to do, the 3D prints. Pamela did a lot of section sketches that I try to translate into 3D. Shamil, we all worked on the design actually, because we all kind of just love it. But then once we settled on the design, then Pamela went really deep into the analysis. She always makes sure that everything we do actually works. And that always pushes the aesthetic thing, because I think when things actually work and perform and it's being formed by many parameters, that's when it looks interesting, hopefully.
And I would add also that this is very typical for also real projects. When we work with Behnisch and Knippers, it's not unique to ACAW. Like when we're brought into design projects by Behnisch, we're brought in at the beginning of the design process. So we give feedback about how what thermal performance goals are going to drive the design and the climate analysis and all of that. And I think it's probably the same for the engineering part.
Yeah, I mean, working with Behnisch and you guys all, I think the design process is very non-hierarchical, and we all have kind of a voice at the table outside of our discipline. So I think that's unique. But not necessarily, maybe it's unique in North America, but I think it's a really pertinent question, because the other thing we have all in common is that our companies are founded in Stuttgart, which is a very random place that, it's not New York or London.
I think Dima's the only one who works in Berlin.
But if I was just going to add like the history of like engineering and architecture in Stuttgart, if anyone's familiar with it, it sort of is based on that multidisciplinary approach to design. The history, I think Frei Otto was like a very influential figure whose research was very interdisciplinary, and his work has led, I think, in some ways to the way we all work as engineers and architects together. So
I just wanted to add that normally as a facade engineer, we have a limited role in the project. You know what I mean? Like once you work with an architect, you start to convince him a bit to change something. Then they say, no, you're in the technical part, please just stay there. We like the concept. Stay away from it. So what I liked with working with the colleagues, it was so open. You can add whatever you want. You can, even with Boston Valley, I mean, I asked very transparent questions. They were very transparent and they gave us all the accurate information. So it's a multidisciplinary, work with a team spirit. And that's why we got that more. And I mean, perfect. Design, I would say.
Yeah, we have one more here. Did you want to? Oh, you got it.
Question about stormwater management. Is there any thought about the extension of stormwater and slowing it down? Just repeat the question.
I'll repeat the question.
He had a question about whether or not we considered stormwater runoff and integrating to the system. Actually, this whole design came out of something that Eric, who is in our office, he ran this project that we did at Harvard where we had like all these terraces, this cascading water, and it was all about managing stormwater runoff. So I would say that this is like a micro version of that on a facade, but I mean, it would be cool to think of it as a next step. I don't know, Eric, if you wanted to add anything. We did think about using air conditioning, all this excess water. I think there's some crazy statistic at some lab building in Cambridge where how many gallons of water do they waste a day for air conditioning? It was some crazy number, but like dovetailing with these systems and tapping into loops, I think would be another great extension of the research.
Capturing condensate and reusing the condensate on all of these systems, putting it in a tank and then running it to the top. We're all in. Let's look at that.
Okay, great. Thank you very much.